We're now going to get into some of the work that's going on the ground. Disease progression first up, and I'm going to ask Mike Manning to come up here and lead us through that. Mike, once you're done, David, if you could follow him, and Joelle, if you could follow David, that'd save me popping backwards and forwards here. So without further ado, let's get on with it.
Okay. I want to talk to you about some of the work we're doing in the district at the research station, and I've got a whole lot of collaborators here. I'm the very awkward spokesperson for those people, not a great speaker, so I hope you bear with me. I'll just get straight in. The first symptoms that a lot of you folks will have seen this, but I'm just going to sort of quickly run through first few slides, how we encountered PSA when it first occurred through the next few months. We noticed, obviously, in a couple of orchards, things like this where we had fruitlet death, these little fruitlets here that have been killed, but not a lot of fuss really to begin with. But then later on, we noticed that we were getting these spots and things like this water-soaked region here, and you notice the death of the fruitlets there. And so that really got us going with this disease. We followed quickly by this sort of shoot death, and you can see here characteristic symptoms. We'd never seen this before in New Zealand. We'd obviously seen something like this in Italy, but not New Zealand before. So carrying on, it got worse and worse, and this was a very bad scenario where we instantly lost a few orchards. And so I want to just move into what we looked at studying in our team, quite a large team in Auckland mainly, and in Te Puke Research Station. We wanted to immediately get some data on the progression of disease in orchards, because you have to, with a disease such as this, you actually have to know how it's operating. You have to understand its disease cycle, and we hoped we could do that. We started that pretty early in December. We had another little project which we thought was valuable to do, which was to look at the spread in the wood and look right through the vine and see where the bacteria were colonized, where it was sitting. For obvious reasons, we were hoping we could help with orchard management. So, how to get rid of that sort of disease tissue, whether we can leave some more of the vines in the orchard. And a very important thing straight away we recognised is that we had about 54,000 different vines in our research station right in this zone that were going to be exposed to the disease. And as soon as we could, we got to looking at every vine in that orchard and finding out whether some were falling over early and others were sort of hoping for resistance. So just to run through some of the leaf symptoms, just quickly, this leaf symptom here is, this is on Hayward. This particular one has sort of round spots and halos, quite distinct. You could have these blocky spots like this, rather looking like houses and so on, all very sharp, angular, with halos. And we could even have spots like this that were angular but no halo. And so we had this, the only way to tell whether any of these are PSA was to do this fantastic PCR test, which is to take material back into the laboratory. That was a bit tedious to begin with, but we did that. But when we looked at leaves in the orchard, I've done this work with Ian Horner chiefly, we started to photograph in December leaves, and I've done it again, leaves, and you can see that in the ones on Hort 16A, you can really see that the spots haven't changed between December and March. and that means that the infection was probably walled off. When we looked at Hayward, and this is not an absolutely typical Hayward infection, but this is just angular spotting here that has actually, between December and March, has actually, the centre of them has gone, but they haven't spread through the whole vine, whole leaf. They only do that if there's an extremely heavy infection. Okay, so where were the spotty leaves on the vine? So our next part of our work was to look carefully down marked canes and look at the shoot development, look at the leaf development of, and particularly spots, and where are they. And I just have one little piece of data to show you. This part of this graph is proportion of shoots with PSA. So up here, it's the higher is more PSA on these shoots, and you can see that through the season, which is this is the date down here, some of them remain pretty well the same, but more than half of them progressed. The actual symptoms down the shoot actually progressed. So we were getting an increase in numbers of leaves that were showing infection throughout the summer, and that has implications for control. So that's just one small piece of the data that we're looking at the moment. And I know this mightn't be terribly impressive, but it's getting to know the disease that we're after. A summary of what we found in orchards. We looked in Hayward orchards, Hort 16A orchards. We looked at low virulence properties and high virulence. It's only 14 orchards. Some of them were taken from us pretty early on. The leaf spotting showed little change in number or size of leaf spots throughout the summer. The spread in the orchards, the problem we faced is that PSA was active and capable of starting new infections throughout summer. It didn't stop. We've gone through winter now, and we're starting our program again, looking at orchards, similar orchards, and some of the same orchards, and doing the same work. If we move on to wood symptoms, March, or right throughout the whole of the season, summer season, we were getting these sorts of symptoms. The dreaded red ooze, and usually, most often, we can get PSA from those symptoms. Another symptom that people have mentioned in the past quite a bit is the very almost pure bacterial ooze that comes from pressure once the bacteria build up in the plant material, and then just forces its way out. And this has forced its way out here somewhere, and this is full of bacteria. I will expand on that in a few seconds. But just another horrible ooze picture, I suppose, just to know the worst that you can get. This is horrible red ooze here, and usually PSA associated.